Hello, everyone, and welcome to another episode of the Lab Lounge, the podcast dedicated to the Skill Up project. Once again, I am the host. My name is Alexandros Chatzigeorgiou, and I'm the project manager of Skill Up. And today we're honored to have two guests from our consortium from the University of Macedonia, which I would gladly call to introduce themselves.
Thank you, Constantine, for the invitation. I'm Alexandros Chatzigeorgiou. I'm a professor of software engineering in the Department of Applied Informatics at the University of Macedonia, currently also serving as the Vice Rector of Extroversion and International Relations.
Thank you.
I'm really glad to be here. Thank you.
I'm also glad that you're here, Professor Chatzigeorgiou.
Hello also from my side. Constantine, thanks for the invitation. I'm Apostolos Ampatzoglou, and I'm an associate professor in the University of Macedonia, Department of Applied Informatics, in the field of software engineering and architecture.
Thank you very much, Professor Ampatzoglou. And the topic that we're going to discuss is very timely, I must say. Software engineering, the thing that we will discuss, is growing large in the recent years. And actually, many people are discussing about doing reskilling from their positions and transition into software engineering. And this creates one question that I would like to share: reskilling for what exactly? So, there is a myth that the demand for developers is infinite, and that we always hear that if you be a software developer, you'll never run out of business. So, is that true? And all paths of reskilling lead to employment in that sector?
Well, that's a very, very interesting question. I would say that currently in our region, the region of Central Macedonia in northern Greece, there is an infinite demand for developers. There has been a very recent study by one leading consulting company for the IT skill shortage in Greece. And the numbers tell us that there is a shortage of approximately 8,000 people per year until 2030. So currently we're facing a situation, especially in my city, Thessaloniki, where all the software development companies that existed here, and the recent ones that landed over the past 5 years, are desperately seeking developers. So it seems that all paths can lead to employment for junior developers, for senior developers, or for experts in particular domains. Obviously, nobody knows whether this trend will remain that way over the next few years,
Yes.
especially because of the advent of AI and AI-driven software.
Yeah,
And
get
we
into
also
that,
don't
yeah.
know whether the situation is the same, the pattern is same all over the world. But currently, we are facing this, as I said, desperate need of companies to hire software developers. It is actually one of the primary factors of foreign investors when they are examining the opportunity or the possibility of establishing offices here in northern Greece, whether the supply will be sufficient for their needs.
I see. But I mean, the situation in Greece is one thing, but how do we face the fact that many other markets, regional or sectoral, may be oversaturated with developers? How do we face the fact that many people, even if they transition and reskill, they may not find employment due to oversaturation, maybe?
I cannot share experience in that direction because even the people who reskill to software manage to find a job, a decent job, and very quickly. To give you another example, we recently, through a partnership with one of the leading companies here in our region, we established the first in the city professional graduate program of studies. This is a purely a program which has a pure reskilling objective. The goal, to put it simply, is to reskill graduates from departments like physics, chemistry, civil engineering, who are largely unemployed in Greece, and turn them after 1.5 years into junior software developers. I think this is feasible. The interest for this particular program is very high. So even for the ones that lack the relevant background, the opportunity is still there.
Oh, yeah, I see. That's very encouraging. And I believe that, I believe that the demand for developers will always be a necessity, even with the advent of GenAI, but we'll get into that in another question. So, okay, I believe that most of the audience knows the technical skills that are required for software engineering. I mean, like things like frameworks and Python, JavaScript, whatever. But I would like to discuss about the soft skills for software engineering and what do non-software engineers bring to the table? I mean, many of the people that will transition in that field will bring other expertise, maybe other communication skills. How can that fit into the software engineering domain?
Yes, this is also very interesting, especially by considering that the myth that the software engineer works in some kind of basement alone,
Yeah.
writing code in the dark is becoming completely not true lately, especially during the last years with the rise of collaborative software development, the use of agile methodologies and the like. People tend to work in teams, so there are a lot of there's a great need for communication even among developers themselves, but also communication with the clients, writing reports. So soft skills are essentials for software engineers, and in that respect, there is a need for changing our curricula as universities, providing software engineering hard skills to include such skills as well. On the question on if people from different disciplines can bring that, I can share an experience from a past program that I was teaching. There was a joint course between marketing people and software engineering people, and we were having a joint assignment for that course. And we prefer to do teams that were mixed, so 5 software engineers, 5 people from marketing, and for me, that was a living example of how differently we educate people in software engineering and maybe the lack of teaching or training soft skills in this curriculum they need, because marketing people, even though they were not 100% sure what they were presenting in their presentation, they lacked technical details, they were able to sell their work better. So
Yes.
in that sense, even from the very early stages of education, it is very important to include soft skills teaching in our curricula and provide junior software engineer with such skills that will be very useful in their careers.
I see. I see. I mean, it makes sense. They were from marketing, so it makes sense that they were able to sell their work, let's say. And so I have another question, follow-up question on that. So, given that we recognize, of course, the importance of soft skills in software engineering, could that maybe, how can I say that? Could we remove the middle management in team communication? Could we trust software engineers with soft skills to communicate among each other and take decisions themselves? Or do we always need an upper management, let's say, to monitor the progress?
I think it's inevitable to have some kind of middle management. You cannot have teams that are all junior developers and no lead
Surely,
developers. So,
yeah.
especially for the worst case of conflict management or for some advice. But recent methodologies are trying to push for equality in the teams. So, for most of the cases, people are equaling their teams. They make decisions collectively. In methodologies, for instance, like Scrum, there are these meetings where you report what you have done, what are you doing today, and you are having a common ownership of the product. So decisions are taken
I see.
collectively by the team. However, I think that the role of the manager will never be out, because this is also something very important. In the end, someone needs to have the overall idea of the product, where it is going, and as I said before, also some decision making and conflict resolution.
Yes, yes. For
And
one
also,
thing, as a project manager, I'm glad to hear it, to be honest. So, okay. Okay, thank you. That's very
so
interesting.
you will not be out of job, don't worry.
Yes, yes. Thank God. Okay, so and another point is that okay, so we know that we need technical skills, and we know that we need non-technical skills. But the point is that are we teaching the right skills in reskilling programs? I mean, there are many programs that are very shallow. They teach, that they they just touch the tip of the iceberg and they don't dive into the necessary skills. And this fast track of reskilling, there's a growing concern that we're creating code monkeys and not actual developers that have actionable insights, they have real world experience, and they can apply this knowledge in practice. So what's your opinion on that?
Well, I'm well aware of these challenges when reskilling people. This has been discussed over and over again in our department because numerous times we have discussed the possibility or the potential of having conversion programs, especially at the master level. Obviously, these programs are much shallower than the conventional computer science programs. However, we have to take into account what we actually need in industry. I would say that for 8 out of 10 jobs, we don't need any deep knowledge. We need knowledge that can be problems that can be tackled by developers with limited experience. Of course, once in a while, deep, complicated problems will arise, and then someone has to deal with them, especially when it comes to critical systems. As I shared this experience of our very recent graduate program, professional graduate program, now we see, for example, that all these graduates lacking the background on mathematics and computer science, they face difficulties in attending and completing the program itself.
Yeah,
I would say that if there is a need to define the quality in reskilling programs, that's not so much related to the technical capabilities that people possess after completing such a program, but I would define quality as related to their ability in integrating into already existing teams. If they manage to integrate, because a lot of learning, we know that takes place in the working environment, if they manage to integrate, then everything is fine, we don't have to worry. If they don't integrate, then this puts a big question mark, which should the department should take carefully into account in order to rethink about this strategy of reskilling.
But the question remains that, okay, I mean, we know that non-technical people need to be integrated into teams effectively, and I, of course, agree with that. But how can we achieve that with real-world practice, even when they study a reskilling program? I mean, okay, when we call representatives from companies and do some talks and some demonstration, this is fine and everything. But could we maybe invest in integrating the students in real-world environments, particularly not even for internships, but during their studies? Can universities play a larger role in that?
I think the landscape of academic teaching, especially in technical disciplines, is changing rapidly over the past 10 or maybe even 20 years. For example, in many programs, we try to embed too many assignments or a good number of assignments, and also capstone projects, which means that the students, beyond simply studying academically a topic, they try to implement as many of the theories as possible. So, of course, internship programs during their studies are important, but a very applied and hands-on experience during the courses is also of importance, not only to test whether the students are capable, but also to increase their confidence. Because this is another problem in technical disciplines, especially in IT, that people often graduate, but they lack the confidence that is needed in order to enter the market. And this is also related to the overarching topic of AI, because nowadays people might gain this confidence simply because they manage to copy code from an LLM.
Yes.
So the ability, as I said, to integrate with others within a team and be part of a team that produces actually tangible outcomes is highly important.
Yeah, thank you for the. This is a wonderful transition because I want to address the elephant in the room. So AI, we all know that LLMs are huge nowadays, and of course, software engineering will not be unaffected by this transition. So ChatGPT, LLMs, all these tools, they're wonderful, but are they augmenting, are they facilitating, or eventually are they replacing developer tasks? So will they eventually boost productivity, or we will just, have four LLMs doing all the work in the company and we will be unemployed, let's say?
Of course, as it was mentioned before, we cannot be sure what is happening in 5 or 10 years by now, or in a year by now, with uh, the investment that it is being put on LLMs in these research directions. But I think that as the current situation is, I do not perceive AI as a competitor or a replacement for the developer, but mostly as a copilot. It is the name of one of the most known LLMs in the software engineering domain. As I see it now, the developer is using LLMs, is using generative AI for sure, and probably in their everyday tasks, to get some understanding of how to solve a problem.
Yeah.
So the normal and the useful way that I see AI being used in software engineering is to replace, for instance, a Q&A forum where you would ask, how is this problem being solved? Or please remind me of the bubble sort algorithm or something like that.
I see.
It is not necessary to browse the web or to go to a forum and ask. You can ask ChatGPT and you can get your question, and even with some explanations that would be helpful. But I think that we are quite ahead from, quite away from the point in time that we would not hire software engineers to write the code with the use of AI,
Yes.
but use AI to write the complete programs from the beginning to the end. And of course, the situation changes dramatically by role. So in a software engineering discipline, it's not only developers. We are having people that are taking requirements. We are having people that are doing design, architecture, selection of technologies, stuff like that. And I think there the human factor is very important. And I think that at this point, there is no big risk for that. Maybe, as I said, in 5 or 10 years, the situation would be dramatically different.
Maybe.
But even what studies showcase by comparing human code with Gen AI code, it seems that Gen AI cannot effectively solve any kind of hard problem that a person, a human, would be able to solve efficiently. And with efficiently, I mean with a lot of testing, with good quality, code that is understandable, maintainable, and so on and so forth.
So this is very interesting. So this means that this means basically two things. From my understanding, is that Gen AI cannot properly understand some more advanced stuff like architecture, varied architecture, or architecture that should be adapted to different requirements, but also that some human skills will remain irreplaceable in whatever time passes, right? So what are these skills? Can we maybe define some software engineering skills that no matter the advances of Gen AI will always remain a human attribute, let's say?
Someone who would be fanatic with architecture, for instance, would say that there's always would be the need for a human architect to take a decision on what components we are drawing and stuff like this. And in the end, the code would be crappy and no one would be able to maintain.
Yeah.
On the other hand, on the completely other end, a person who is very much in favor of Gen AI would say, okay, I wouldn't care about that, because in the end, the code that is being maintained, it is going again to be maintained by Gen AI. So no human would need to understand it.
Yes, I
So
see.
there are two completely different edges on that. So there are people that feel that this whole thing is at a big risk, and people that are very confident that their jobs are safe. I think the reality is somewhere in the middle. Alexander, I think that you wanted to add something.
No, I think that when we discuss irreplaceable skills, there has been a lot of focus over the past few years on the soft skills that are needed.
Yes.
Of course, soft skills are needed in every career path in order to excel as a professional. However, we have to remember that without technical knowledge, nobody can produce anything of value in industry.
Of course.
So we have to tell our students that they should stick with the fundamentals, they should stick with what their departments or schools offer, and also understand the need for performing well in a team, being able to present work to others, being able to present themselves, and so on. So the two can work only if they exist together.
But that's very interesting because we speak about what the universities have to offer, but one primary question is, do they offer the right stuff? I mean, should we, given the advance of GenAI, should we still teach people to code line by line? Should we integrate new skills like prompt engineering or basic literacy in AI? Maybe some new courses could be introduced. So what's your opinion on that?
That's a good question, and I'm not sure that anybody can be very dogmatic about this particular issue. However, I still think that the fundamentals, and by fundamentals I mean mathematics and statistics, are highly important for everyone that wishes to enter the market or be associated with any CS related job, especially for statistics, because many people do not even know that current machine learning algorithms are essentially a repackaging of previous statistical approaches that existed for years.
Yes.
Then
Yes.
this is a truth that is not often said.
No, it
Well,
took me years to figure it out myself, to be honest. Yeah.
well, for any student in a computer science or software engineering department, what we always tell them is that there are three skills, technical skills, which are highly needed. The one is a good knowledge of a programming knowledge, and by good I mean a satisfactory level, because you cannot know everything. Even if you are an expert in a particular language, the languages themselves evolve.
Surely.
Then they should have in their arsenal a good knowledge of data structures, because data structures is what really can make a developer really productive and differentiate him or her from the others. And then they should also have this quality of or willingness to learn and use libraries. And I'm insisting on the willingness rather than the knowledge, because the libraries are millions, are uncountable. So the only way to survive is to be interested and willing to learn, find them, learn them, and experiment with them.
I see.
Of course, over the past few years, we have also seen that the skills related to, let's say, higher levels or system management of software systems are on the rise. And by that, I mean skills on managing or handling repositories, on the deployment of systems, and also on testing. Over the past years, we thought that the testing team is always a diverse one, and someone else takes care of system or integration testing of the things that we build. Nowadays, with AI and machine learning pipelines, I think it is imperative to be able to test the code. And by testing, I do not only mean the functional correctness of the code, but also the performance of these systems.
Yes, of course. Performance is very important. Okay, these are very interesting insights, and let's circle back to education, given that you also teach at the university. So let's say that I'm a common citizen. I work in another sector, maybe civil engineering, electrical engineering, anything really, and I want to transition into tech. So what makes a successful transition? Are there any transferable skills? Should I have a specific mindset? And eventually, what support systems should I seek? Should I seek online courses? Many people choose online courses, but I'm not sure if this is the proper way. Or some boot camps, formal programs like the one that you mentioned that you have in the University of Macedonia. So, what are the guidelines? Let's say here.
In terms of mode of instruction, a good mix of everything is probably the right way to go, because nowadays there is so much high quality material online that it would be a pity not to take advantage of it. Formal education, at least in Europe, remains a priority, because it is at one point or another in the career path of someone will request a formal proof of his education. So this is considered important nowadays, at least. In terms of transferable skills, I'm again getting back to the fundamentals of mathematics and statistics, because if someone possesses this fundamental knowledge, then it is relatively easier to hop on from one technology to another. Of course, technology stacks are changing rapidly. The ability to learn over and over again and to experiment with new technologies. And by experiment, I mean writing code, dropping it, rewriting it, literally experimenting is probably skill number one.
Yes.
Because this is what we usually see with people when they get older in the programming field, what they don't have any much energy to do anymore from one age on, is this ability to experiment with new technologies. Usually people want to sit on the technologies that they know very well and do not shift that much.
Yes.
However, this is inevitable. Nowadays, I think that we will face very rapid changes in the technological infrastructure and the tools that we will use every 2 years.
Yeah, no doubt on that. Professor Ampatzoglou, any additions on that?
Actually, no, more or less. I was also
Okay,
wanting
thank you.
to refer to the fundamentals, as Alexandros mentioned. But maybe what we can do, or what we can advise people who want to do such a transition, would be to try, apart from the fundamentals, to also follow rapidly growing technologies. So technologies that might be more demanded in the market in the next years. So languages, for example, like Python or like Rust might be most wanted in some years from now. So someone who wants to do a very fast track transition can also, after getting the basics from Java or C++, or the fundamentals of programming, can invest their time in a language that supports, for instance, generative AI or machine learning pipelines, so that they can also go into other domains. So, for instance, at this point, software engineering is everywhere. It's not only in ICT. It can be considered as part of many disciplines,
Of course.
because everyone wants some kind of coding in the sense of some kind of data analytics.
Sure.
So the domain and the market might be becoming even larger in this respect. And after getting the basics and the fundamentals as described before, focusing on such languages would be something that might help a successful transition.
Okay.
Some years ago, this would be web, for example.
Yes.
Now it is machine learning. In the meantime, it would be cloud services. But again, technologies are changing so rapidly that in the last 10 years, the focus, or what it is trendy, has changed a lot.
Yeah.
So in the last 10 years, you could say that I need to learn mobile, I need to learn cloud, I need to learn machine learning, I need to learn web. And it is 4 completely different things. So in the end, we go back to fundamentals.
Yeah. Now it's just I need to learn AI or something. I don't know.
Yeah.
Okay. So yeah, I said the last question for both of you actually. So the point is software engineering becoming the new literacy, let's say, for not only for engineers but for everyone? So as you said, coding and software engineering is increasingly expected in many domains beyond ICT. So should we embed software engineering skills in software skills, let's say, in all curricula? Are we seeing softwareization, let's say, of traditional roles? So shall we invest on this, or it will all just be a bubble that will burst sometime?
In a recent study, we investigated the landscape of software development in other disciplines, and it came out that there is a lot of software that is being written in other disciplines like physics, medicine, industrial engineering, chemistry, and so on and so forth. What we also observed is that the quality of code in these disciplines is not perfect, which is reasonable. And there are also some very distinct differences to the challenges that we face in software engineering or when dealing with industrial software development. And the primary observation is that these systems do not evolve that much. And if they evolve, their quality might be deteriorating because these people lack the skills to apply practices which are mainstream in software development. For example, they are not that familiar, and this is again reasonable, with quality assurance tools. They are not familiar with practices in software development that render the code understandable and maintainable. They also lack the skills to handle repositories and mine information. Of course, there are exceptions. We have seen superb software engineering in other domains as well. These observations lead to the conclusion that software skills have to be embedded, and I think they have already been embedded in all engineering, but also in other hard science curricula. We see CS 101 courses in all sorts of fields. There is a risk, however, especially with the ability to write easier and a lot more code with AI, and the risk lies in the perception that people might gain that software is easy to write, so there is no need to resort to discipline and systematic approaches. This is okay for toy examples or for experimental software. This might turn into a problem when it comes to crucial software or software that might have important impact on life or might yield economic losses.
I see. Professor Ampatzoglou, your position?
I also agree, actually, that software is everywhere, as I mentioned before. But also I see this problem of staying into the surface. So I also see this as a risk, as Alexandros mentioned before. People sometimes get the illusion that they know how to write software. And it is very difficult for a young software engineer to understand that they do not possess really the skill, but they are following the prompts of an AI tool. So this is very hard. At some point in the beginning of the discussion, Alexandros mentioned that with the use of AI, students or young software engineers will get more confident that they know how to write code. This is true, but again, a real story from the class. Once, very recently, that AI is used a lot by our students. One student came to me and told me, I see that with AI I can solve all the exercises. I see that I can get better grades.
Yeah.
But in the back of my head, I have the impression that I'm becoming more stupid than more clever.
Yeah, I get it.
And this is so true. And the level of understanding of the student was very, very nice, because he really understood that he's not getting into depth. And it is rare. The most of people believe what Alexandros said, that they're becoming more confident that I can do it. And this brings the risk. So we need to let the students know that not everything is solved by AI. We need to know the fundamentals. We need to have a background and use it as a copilot, as mentioned in the beginning of the conversation, and not make us consumable by AI.
Yeah, that makes sense.
Well, we have to consider that even the role of the educator will be replaced by AI-driven systems. So
of course,
no one is safe in this new landscape.
Yeah. So okay. So closing off, given what you just said, each of you, let's give me a takeaway or your feelings, your concerns, a message that you would like to convey, a key phrase, let's say, about our topic.
I would say that software is blooming. Software will be pervasive and ubiquitous in the forthcoming years. And this is good for the people who are interested in being professionally involved in this interesting domain. I don't think that we should have fear of AI. It is something that can boost productivity even further. But we should try, as Apostolos mentioned, to see behind the easy solutions, try to gain insights, try to gain knowledge, and be able to interpret whatever is being delivered to us whether they are recommendations or entire systems. So skills are and will remain a number one characteristic for a successful professional career.
So what you say is that we won't reach Skynet or something. That's avoidable. Okay.
Exactly.
Good to hear. Good to hear. So Professor Ampatzoglou, you're.
Yes, I would also suggest with a small message I think that it worth the investment on trying to reskill to become a software engineer. This is something that has huge potential for the future, since softwareization is something that it's very fast growing. Also, myself, I'm not that much worried about AI is eating the world. Software is eating it more.
Yeah.
And a lot of room is there for everyone. But as mentioned, the most important thing is the correct use of AI and changing the mentality of everyone into that, from students to junior software engineers, professors, and managers. Everyone to understand where human skills are needed and which tasks, small tasks, can be replaced by AI or be boosted in terms of productivity for AI.
Okay, sounds like a challenge, but we'll see. We'll see in the next years. So it has been a pleasure. So thank you for joining me in the podcast, and I think that what we learned is very useful for students and professionals alike. Um,
Thank you,
yeah,
Konstantin. It has been a real pleasure.
thank you very
Thank
much.
you. Thank you. It was a pleasure.
Thank you very much. So I hope you enjoyed this episode of the Lab Lounge, and stay tuned for more.